Hello, in this video we will talk about expected value and how to calculate it and how to interpret it. So first of all, what is expected value? You can think about the expected value as a long run average. So if you repeat some experiment over and over and over and over for a really long time, then what will be the long run average of those repeated trials? So for example, say that you have a six-sided die and you are rolling repeatedly and looking at the number that comes out on top. What is the expected value of the die roll? In other words, what is the long run average of rolling this die over and over? So because it's a fair die, we know that the probability that the die comes up 1 is 1/6, and 2 is 1/6, and so on. Each side has an equal chance of coming up, and so each side has probability 1/6. So we can calculate its expected value as 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6. So in other words, we take each one of these faces on the die and multiply it by its corresponding weight, and all of the sides have weight 1/6. Each one of these sides has probability 1/6. So when we crunch this out, we get 3.5, which makes sense because that is the average of the numbers 1, 2, 3, 4, 5, and 6. Okay, next example, we have a certain lottery, and you pay $1 to get a lottery ticket. If you win, you get $1,000, and your chances of winning are 1 in 1,000,000. If you lose, then you just lose that $1 and you don't get anything. Okay, so what is the expected value of the outcome of this lotto? So you need to take into account that the fact that you have to pay $1 in order to play. So first, if we just think about the expected winnings and don't worry for a moment about that $1 that it costs to play, the expected winnings are, let's think first about what are the two outcomes. You can either get $1,000 or you can get $0. And you get $1,000 with probability 1 in 1,000,000. You get $0 with the probability 1 minus 1 in 1,000,000. So here's the probability of winning. Here's the amount you win. Here's the probability of losing. And here's the amount you win when you lose. So crunch this out and you get $0.001. So in other words, your expected winnings, if you play this over and over and over and over again, you would expect to win 1/10 of a cent. Okay, now let's take into account that you have to pay $1 each time in order to play. So the expected value of this outcome is just going to be the expected value of the winnings minus the $1 that it costs to play. So when we subtract off the $1, then we get negative $0.999. So in other words, we can see that if you play this over and over and over, then you can expect to be losing money. You can expect to be losing 99.9 cents each time that you play. So on average, if you did this over and over and over again, then each time that you play, you can expect to lose 99.9 cents. All right, so that is our expected value, how to calculate it, and how to interpret it.